So what you're looking at is you have $30, and what's the height? So you're going to do this. Come on. So this is X, this is 15, this is 15, and this is 10. So 15 times 15 equals 10 times X. 225 equals 10X. 22.5 equals X. So diameter 32.5. Radius is 16.25. Okay. Okay, new stuff.
That's one of the simplest formulas we've been dealing with lately.
There's just so many of them. You got law of sines, law of cosines, you got your regular right triangle trig, you got the area of a triangle using two sides and the angle in between them, you Hero's formula, all sorts of lovely stuff. Yep. Area of a sector, area of a segment. Okay, so what we're looking at today, we're going to look at a box. First, we're going to seriously test my artistic abilities. Yeah, but this one might be a little bit more of a test. So we've got a box. And what we're going to do is we're looking at the path that connects one corner to the far opposite corner. Like that. So what I want to find here is a couple of things. I want to fill this in here. We know that's going to be a right angle down there, right? I want to find this angle here. I'm going to call angle T. And this angle here, which I'm going to call angle R. Now, technically, this is the complement of T. Technically, angle T is this one up here. But if we can find this one, we know that one, right? They add up to 90. Because that blue triangle is a triangle, adds up to 180. Those are two angles from the blue triangle. I also want to find the length of the path from corner to corner. So let's say that this here is 8 millimeters, this is 10 millimeters, and this is 16 millimeters. The length of the path is actually pretty easy. What I'm going to do is I'm going to find this length across here first. So I'm looking at a rectangle that is 16 by 10, and I'm going corner to corner here. Well, what's that length going to be? Assuming these are right angles. Square root of 16 squared plus 10 squared, correct? $18.868 is that length. Now, knowing that length, we can now find R here. Actually, we could find R without that length, couldn't we? Did you see how we could find it? R would have been just the inverse tangent of 10 over 16. So we'll come back to that. Now, if I want to find the length across the diagonal here, I know that base, and I'm looking for hypotenuse now. This is the 8, and this is the 18.868. So it's 8 squared plus 18.868 squared, right? square rooted. But here's the thing. Where did this 18.868 come from? Came from this, right? If I put that in there and square it, what do I really have? Well, if I square this, I just get 16 squared plus 10 squared. So to find that distance across there, it's in 3 dimensions, I can actually just take, it's called Pythagorean theorem in 3 dimensions. I can just take all 3 of the dimensions, square them, add them together, and square root it. I don't have to do it 2 at a time like this. I'll prove to you that this works. So I've got second square root, the previous answer squared, which is 18.868, plus 8 squared. And I get 20.494. What if I had done those all at once? Well, second square root, I've got 10 squared plus 8 squared plus, oops, go back, squared plus 16 squared. I get 20.494. Exactly the same answer. So I don't have to do them 2 at a time. I can do them all at once. Mm-hmm. Yep, down to 8 decimal places. So that length down through there is 20.494 millimeters. So now I can find my angles. R, right here, this is the opposite, this is the adjacent side, so R is the inverse tangent of the opposite over the adjacent. Giving me 32.01 degrees. T, we're going to do this one down here. I know that this is 10 here, or 8 here, and I just found my length. So T, I'm going to put the bar over the top, showing me it's the bottom one instead of the top one. T bar, I'm going to call it. Well, that line over the top is actually the symbol for the complement, which means T and T bar add up to 90 degrees. So there is a mathematical reason for using that symbol. This would be the inverse sign because this would be the opposite side. 8 over the hypotenuse of 20.494. Now, if we were looking for T, we would use the inverse cosine, wouldn't we? Because that'd be the adjacent side. So that comes out to be second sine 8 divided by 20.494. 22.977. This degrees, 22.98 degrees. So there's my angle, there's my length of path. Not so bad. Let's look at another example then. 22.98 degrees.
How about when we should try our goal?
That's where I was going with her. So find T here again. T bar. find R, and find the length. So our length is going to be the square root of 0.2 squared plus 0.35 squared plus 0.5 squared, right? Second square root 0.2 squared plus 0.35 squared plus 0.5 squared. 0.6423 inches. That's the length. R is the inverse tangent of the opposite side, which is 0.35, over the adjacent side, which is 0.5. (34.99 degrees). T is the inverse sine of the opposite side, which is 0.2, divided by the hypotenuse, which is 0.6423. Yeah, that's T bar, yeah. So second sine 0.2 divided by 0.6423. 18.14 degrees. So it's really not that difficult. It's just seeing all the pieces go together. Hypotenuse. Let's give you a new one to try. You know what? Let's do that very forward and go. Yeah, that's easier. So there's my path. Find the length. There's T bar. Find T bar. There's R. Find R. Let's say that this here is 0.250 inches. This here is 0.600 inches, and this is 1.00 inches.
You only give me 5
It doesn't open until 8 o'clock anyway. So our length, we're going to do 0.25 squared plus 0.6 squared plus 1 squared gives us how much? 1927. Do you guys concur? Good deal. R will be the inverse tangent. 0.6 over 1, which gives us what? 30.96 degrees. You can concur? You can concur? T bar is then the inverse sine of 0.25 over 1.1927, which gives us 12.1. Do you agree? I think it's time for a homework packet. In the homework packet, it's going to be page 392. problems 1 through 6.